Good job getting through all the level 1 challenges, and now we're on to level 2, models still taste like chicken. So we're going to be going through some model best practices, starting with name scope, callbacks, some new relationship options, includes, and then finally has many through. Throughout these slides, you're going to see some symbols that look like this, one for bad code, one for good code. That's for your reference. If you go through the slides later and you need to figure out, which is the bad code, which is the good code, just look for these symbols. You also might see some zombies wandering through these slides. They don't mean anything in particular. And you might also see some brains, which means don't get too hungry, but it is organic and no sugar added. So let's jump into name scope. So here we have a rotting zombies controller. Inside here there's an index action where we're querying for all of the zombies where rotting is true. Now we're very often in this application going to be querying for rotting zombies. So you think maybe there's a better way to do this. Well, there is. We're going to take that where method there, we're going to move that into the zombie model. Inside the zombie model we're going to say scope rotting. So we're creating a named scope. The name in this case is rotting. Then back in our controller, we can simply do zombie rotting. It's going to call that method and return all the rotting zombies. Now let's take a look at a few more examples of named scopes, starting with fresh, which gives us all the zombies that are less than 20 years of age. We can also get all of the recent zombies sorted by created at, limit only 3 of them, so we can chain these things together. We can also use method chaining to create queries. So we can say zombie.rotting limit 5, we can say zombie.recent rotting, and then finally zombie recent fresh rotting if we want to chain them all together. In a moment we're going to talk about callbacks, but right now we have an objective. We need to write some code to check to see when the zombie age is greater than 20, set rotting equal to true. First we're going to see how we might implement this badly in our zombies controller. So let's jump into the zombies controller. So here's your typical update action which was generated from our scaffold. In here we're going to say if zombie age greater than 20, set zombie rotting equals true. And you can see I've got that symbol up there to signify that this is bad code. But why is it bad? Well, there may be other places that we're updating zombies and might be changing the age. And if we do that in other places, it's not going to set rotting. It's only going to set rotting here in the update method. So how can we do better? Well, we're going to take this logic and we're going to move it into the model. So here we are in the zombie model. We're going to wrap it in a method called makeRotting. And then we're going to tell it to call this method every time it saves zombies, in this case before it saves it. However, this code as it's written wouldn't completely work. We still have some invalid variables in there. We have those instance variables which came from our controller. So let's get rid of the bad code and rewrite this. We're going to write if age greater than 20, self-rotting equals true, and now it's going to work. Now if you haven't written many model methods, this might look a little odd. Why do we have self dot in front of rotting and not age? Well, it turns out when we call age there, we're reading. So it's going to look for an age variable inside that method. It's not going to find it, and then it's going to look at the scope of our model, so of the instance. So it's going to pull the age attribute. With rotting though, we're actually setting a variable. Since we're setting the variable, if we didn't have self dot, it would set the variable using the scope of just the method, and we wouldn't have access to it outside of the method. So here we specify self.rotting, so it knows we're talking about the attribute in our database. There's one other way we can improve this code, refactor it a little bit, and that is by simply doing it all in one line. We can say self.rotting equals true if age greater than 20. There are a bunch of different model callbacks that we can use, but before I show you them, we need to make sure you understand that returning false in any of these callbacks will completely halt whatever you're doing. So here we have a brain model and we have a taste method. The taste method returns false. In Ruby, we don't really need to have that return method anywhere. We can just say false. This method is going to get called before save, which means it's going to stop. It's going to stop the save from happening. So if we jump into the console, we create a new brain and we try to save it, it's going to return false. We're never going to be able to save a brain. So you just have to be careful of return values when you're doing callbacks, because if you return false, it's simply going to stop. Also, if you're a zombie, be careful of fire. Fire, bad. Bad zombie. Here's a list of all the callbacks that you get access to from inside an active record model. You can see here we've got both before save, before destroy, after destroy. A couple points to be made here. You can use multiple callbacks, even of the same type, so I could have a bunch of different before save methods if I wanted to. And as we mentioned before, if any of these return false, then it's going to stop. And if it's a before create or before save or before update, well, it's not going to get saved to the database. To give you a couple examples of callbacks in real Rails apps, you might have in your user model an after create send welcome email. So every time you create a user after it's saved, send a welcome email. You might also have before save encrypt password so that when someone types in a new password when they create an account, they can save the password, create a salt maybe. And lastly, you might also have before destroy set a deleted flag. So you may never want to actually really delete a user out of your database, in which case you might have a deleted at date time field. So inside your before destroy, you might actually set that date time field and then return false, which would halt that destroy from ever happening. So it wouldn't actually destroy it from the database, but you could still call destroy. It would halt it because it would return false. All right, we're about halfway done with level 2. Next up, we're going to be talking about some relationships. Remember relationships? Back in Rails for Zombies 1, we talked about belongs to, has many. Now we're going to be talking about has one. So our example here is we have a zombie which may or may not have a brain. You can see a zombie has a brain, this one has half a brain, this one has no brain. So how do we do that in our code? First step, we're going to generate a new model. So we can say Rails G model brain. Our brain is going to have a zombie ID, which is an integer. That's how we know which zombie this brain belongs to. We're also going to have a status, which is a string, the status of the brain, and of course, flavor. Flavor is very important for zombie brains. So when we run this command, it's going to create a migration for us. It's also going to create our model. Let's jump into this migration. Inside this migration, we're going to see that it creates the brains table and all of the columns that we specified. We're also going to add one small snippet of code to this migration. We're going to specify a foreign key index on zombie ID to keep our database efficient. If you don't know what a foreign key is, maybe read up on databases. When we're ready to create this table, we're going to, of course, run rake db migrate. Now that we have the database table, we have to represent that relationship inside of our model. So here's the brain model, and here's the zombie model. Inside the brain model, we simply say belongs to zombie. And in the zombie model, we say has one brain. It's as simple as that. Let's jump into the console now and play around with this relationship. So here's our last zombie. Let's grab that. We can then create a brain by just calling z.createBrain, sending in the attributes. And that'll return the brain we just created. We can also just call z.brain in our zombie, and that's just also going to return that same brain. But what happens when we destroy a zombie? Does the brain go with it? Well, let's take a look. So we're going to grab the first zombie. There's our zombie there. We're going to grab the brain of that zombie. There it is. We're going to then destroy the zombie. It's destroyed. There we go. And then finally, we're going to find the brain, and the brain is still there. The brain still exists. We need to destroy the zombie brain with the zombie. Well, how might we do that? To figure out how to do that, we're going to go to railsapi.com and we're going to search for the has one relationship. In there, we're going to see a lot of different relationship options, including the dependent option. How do we use that? Well, let's give it a try. So in the zombie model, we're going to say has one brain, dependent, destroy. Okay, well, let's jump back into the console and see what this does. We fetch our zombie. And then when we destroy the zombie, we can see in the SQL that it generates that it destroys both the zombie and the brain. Active record relationships have a bunch of different options you can use. Not only dependent, destroy, but you can also change the foreign key index if you want to have a different foreign key. You can even change the primary key if you want. You can also specify validate true on a relationship. So in this case, if we had validate true on brain, when we saved zombie, it would also validate to make sure the brain validates as well. If not, it wouldn't save it, it would return false. And there's lots of other relationship options. Check the documentation. Next up, we're going to talk about the include method. You can see up here we have a view. We're listing out the name and the brain flavors for each of our zombie. What might the code look like for this? Well, here we are in the controller. We're getting all of the zombies. Inside of our view, we're going to list out each of the zombies, list out their name, and call zombie.brain.flavor to get the flavors of their brains. And if we look back on our server to see what SQL it was running, we would see this. This is not so good, right? It's doing a query for each brain for each of the zombies. We call this sometimes an n+1 query. It's a bad thing. It's not very efficient. It doesn't scale very well. How do we get around this? Well, this is where the include keyword comes in. So we're going to say zombies equals zombie includes brain all. What SQL does it run? Let's take a look. You can see here it's getting all the zombies and then it's querying for all the brains for all of these zombies. Much more efficient. Lastly, we're going to talk about the has many through relationship. And in this case, our example, a zombie may play multiple roles in our zombie army. We have a captain, a scout, a soldier, and of course a brain taster. And a zombie can have multiple roles. So let's go ahead and implement this relationship. So we obviously have a zombie table, and we have a role table, which could be scout, captain, soldier, and brain taster. Based on the knowledge you have thus far, you might think that we should just add a role ID to the zombie table and then have zombie belongs to role. However, the problem with this is it's only going to work if a zombie has a single role, and we want our zombies to have multiple roles. So how do we do that? Well, we're going to need another table. We're going to need an assignments table which sits in between zombie and role. Inside that assignments table, we're going to have a role ID and a zombie ID. Through the role ID, assignments is going to belong to role, and through the zombie ID, assignments is going to belong to zombie. On the other side of the relationship, we're going to say zombie has many assignments and role has many assignments as well. Before we jump into has many through, let's create the migrations for these tables. So here we have create assignments. We have a zombie ID, which is an integer, a role ID, which is an integer. Lastly, we're going to have two foreign keys, a zombie ID and a role ID. We also want to create the roles table, which is going to be really simple. It's only going to have a title, like captain or soldier. Now let's jump into our model. So here we have the assignment model, which is going to belongs to zombie and belongs to role. We'll have our zombie model. Zombie has many assignments, and of course, role has many assignments. Now here's where things get interesting. We need a way to represent the relationship between zombie and roles. That's where the has many through comes in. So we're going to say zombie has many roles through assignments. We can represent the other side of the relationship. We can say role has many zombies through assignments. Okay, now that we've declared these, let's jump into the console and see what it looks like when we start coding some Rails. So we can say zombie last. We're going to fetch the last zombie. We can then give a zombie a role by doing z.roles, role find by title captain. It's the same thing as just doing push. It's just an array. That's going to query for the role, and then it's going to insert a row into assignments to represent that. We can also call z.roles to get all the zombies' roles, and that's going to do a single query doing an inner join on our database using both the assignments and the roles tables. So we've reached the end of Models Still Taste Like Chicken. Now it's your turn to get your hands dirty with the challenges. Good luck.